Hello, this is video one of topic 4.1. We are in unit four. Unit four starts to take us into the world of applying the derivatives that we've been working with in units two and units three. So we've been spending a lot of time taking derivatives, but we haven't really talked about the why. Why are we taking derivatives? What do derivatives tell us? And so section 4.1 is telling us that we can interpret the derivative within a specific context based on the fact that the derivative is the instantaneous rate of change. So I just want to reiterate some things that we've talked about before, which include that if we're given a graph, for example, this graph of f of x, and we're given a line tangent to the graph f that goes through the point 1, 0. So we're talking about this point right here. So we know a couple of things. We know that this point is both on the tangent line and it's on the curve, right? But what we also know, or I guess it is given to us, is that f prime of 1 equals 3. So what does that mean? Well, f prime of 1 equals 3 means, I guess I should write the full statement, f prime of 1 equals 3 means that the slope of the tangent line at x equals 1 is 3. So a couple of things we need to keep in mind. The slope of the tangent line is important because it tells us also that the slope of the curve at that one moment in time, at this instant when x equals 1, is also 3. So what's special about that blue point is that at that blue point, the curve function of f of x and the linear tangent line have the same y value, but they also have the same slope or the same rate of change. And so that's why we worry about finding the slope of the tangent line, is because that really is the slope of the curve. So up to this point, this is what we've said, that f prime of 1 equals 3 means that the slope at x equals 1 of the tangent line is 3. But we're going to start to now look at derivatives with some context. So we're going to start to see derivatives now in what you would call a word problem, right? So a couple of things to remember. We usually use different variables depending on whatever they're talking about, right? So we don't always use x and y. We might use v for velocity. We might use capital A for the amount of whatever. We might use v for volume. We might use t for time. Second note, we need to remember that derivatives always have units, especially when we're talking about a context. So the units are always the units of the vertical axis, or the y's, if you will, and the horizontal axis, or the x's, if you will. And then the third thing is, whenever you see the word rate, they're talking about a derivative, because a derivative is an instantaneous rate of change, which is also talking about the slope. So we need to make sure that we remember those three things are not only related, they're equivalent. The derivative is a rate of change at a specific moment in time, and it's the slope of the tangent line of a curve. And then the last part is that the derivatives are always defined as instantaneous. So we need to know at what instant this measurement is taken care of. So in this table, we kind of have a nice summary here. So derivatives are rates. So whenever you read the rate of whatever, you know that you're talking about derivative. They're always instantaneous, so you always have to know the rate at what time or at what moment. And then the derivatives always have units, and the units come by taking the units of the y-axis or the vertical axis and versus the units of the x-axis. So kind of how you do slope as rise over run, the change in y's over the change in x. Find the units of the y and put them over the units of the x axis, if you will. So let's look at something like this. The height of a sunflower in inches is measured over the course of 7 weeks. Can we use a table to estimate h prime of 2 and include units of measure? Well, a couple of things to note. They want us to estimate h prime of 2. They want us to estimate the derivative. We don't have enough information to take a derivative the way we've been taking the derivative with all the rules. So we're going to have to estimate it. And the way we estimate it is to choose points that are close to that time measurement. Remember, this is your input, time. This is your output, height. And so when I look at this, the closest time measurement to 2 are this one and this one. So 2 is somewhere in between. So let's use those two to estimate. How do we estimate? Well, we estimate by taking a slope. So h prime of 2 is about the slope at 3, which would be 25, minus the slope at 1, the output at 3, which is 25, minus the output at 1, which is 7, divided by 3 minus 1. So it's the change in the y's over the change in the x's. Knowing that, we can just subtract straight across. We'll get 18. Subtract straight across, we get 2. And our answer will be 9. But what are the units? Well, these values were measuring inches. The bottom values were measuring weeks. So then this is 9 inches per week. This is our estimate. Now notice, I put the estimation symbol here. All of this work is an estimate of the derivative because we're looking for the slope of the tangent line. And now we found that the slope is 9. But more specifically, it's 9 inches per week because we were given units to begin with. That's how we're going to approach finding derivatives and using units to figure it out.